Hello students. Today I am going to prove a different type of problem based on irrational number. In my first video I used to prove square root to irrational number. Now I am going to give a different type of proof for irrational number. In class 9th you studied properties of some irrational numbers. First, sum or difference of a rational and a irrational number is irrational. For example, 2 is a rational number, square root 5 is irrational number, therefore their difference is irrational number. And second one, product or quotient. Quotient means I am talking about divisions of rational and irrational number. So product or quotient of a non-zero rational and irrational number is irrational. For example, 3 square root 2, 3 divided by square root 5. So I am going to prove some particular cases here, and I am giving you some key points to remember before going to prove. First, we will use contradiction method. This contradiction method I already discussed in my previous video, so if you have any doubt about this method, so look at my previous video. And second, assuming given expression equal to a rational number, we will try to get value of irrational number that is involved in our expression. So if 2 minus square root 5 is given to you, then you have to solve for square root 5 and find out the value of square root of 5, what will be you get. And third, then we will use irrationality of this number to get a contradiction. So in this type of question, the one thing that you know, that given irrational number is irrational, you can use this in your proof. So what will you get? A irrational number equal to rational number. So when we arrive to this contradiction that irrational number is a rational number, so this in turn prove our results. So we are now ready to prove 6 plus square root 2 is irrational number. What do we want to prove? 6 plus square root 2 is irrational. Suppose on contrary that 6 plus square root 2 is rational. This is our incorrect assumption. I am taking this incorrect assumption because we are going to prove this problem by contradiction method. So 6 plus square root 2 equals to p by q, where p and q are integers and denominator q not equals to 0. And suppose p and q are co-prime, that is they do not have common factor other than 1, or similarly you can say that their HCF is 1. On rearranging, what will we get? We will get square root 2 equals to p by q minus 6. On solving, square root 2 equal p minus 6q upon q, that is our equation 1. So what will you see? Since 6q is integer and p minus 6q is also an integer, this statement I am saying because we know that multiplication difference of two integer is an integer. So p minus 6q is an integer, q also is an integer, and integer upon integer, that's why this is a rational number. But we also know that square root 2 is irrational. So what equation 1 will imply? Square root 2 is irrational number equal p minus 6q upon q, that is a rational number. So equation 1 implies rational number equal irrational number, which is not possible because we know that a rational number cannot be equals to a irrational number. For example, you can take square root 2 equals to 5 by 6, their value cannot be equal. So this contradiction arises due to our incorrect assumption. Hence, what is our incorrect assumption? That is 6 plus square root 2 is rational. Therefore, what will be the correct assumption? That 6 plus square root 2 is irrational. Hence, this contradiction prove our result that 6 plus square root 2 is irrational. So thank you for watching. If you like, then share my video and subscribe my channel. Here is the link.